What's up, guys? It is day 71 and a half of programming every day. I just finished my File Explorer project, and now I'm going to get started on our operating system that I wanted to create. I have no idea what I'm doing, right? So I'm going to follow this tutorial by Nanobyte. I'll leave a link in the description to his tutorial series. So yeah, let's get started. Okay. So let me make sure I have QEMU installed. Oh, what is this? Is it just QEMU? QEMU base. Yes. Okay. Well. Oh, don't tell me. QEMU's just not QEMU desktop. Yes. As it seems like either the server's down, yeah, or we're just having problems, so we might have to build QEMU from source. Linux. Yeah, see, I do pacman-s QEMU, but 3. Just install everything. But as you guys can see, it's not working. So, I think what we're gonna have to do is we're gonna have to install VirtualBox Arch Linux. -s virtu. Just do the default. There we go. I wonder if QEMU is deprecated. It could be the case, but so, okay, let's, oh, I was about to say let's go back to the video, but, oh, that's not what I want. Oh my god, my operating system is dying. Why did this open? Why did my library open? Four minutes in. Okay, everything is breaking. Let's just... Okay, there we go. Okay, there we go. Actually, I think it's because, yeah, we're using a lot of CPU. Okay. So add AX7. Does that add like a integer? Okay, let's see. Let me make sure I have not some symbol too. Oh. Okay, I already have it. CMake. Okay. Cool. So make a source directory, or actually, remove this. Delete that. Make directory OS CDOS. Make a source directory. Okay, so your operating system's copied into RAM for the first, and then it's stored at this memory location. Okay, sounds simple enough. So I think the main struggle of this project is going to be RAM and memory. But maybe not. Let's see. How is it? Okay, so create a main assembly file, org, and then that memory address x or 0x7c. So this will put our what we have saved here into the RAM to start, so the BIOS could find our operating system. So that's pretty cool. Gives a clue. So we declare that it's a 16-bit operating system. 16-bit operating system. Okay. So if we wanted to, which we will in the later parts of the video, we will translate up to 64-bit operating system. So this right here is the memory address we have to send our operating system to, so the BIOS reads, I think is what he said. Okay, so we have to call the main function this is where our code will be. And then halt. Halt. I guess halt's a function. We jump to dot halt. Hold me now. I'm 6 animal. So we'll do about an hour a day. So I forget. I think it's like section dot text, right? And then you define like help db hello, and then you'd put the amount, right? That's how it is. I totally forget. Times repeat given instruction or piece of data a number of lines. So this repeats our data. Confused. Five, 10. This? Sorry guys, I can't really see. Let me up the quality. See, there we go. So it would be times equals 8. I'll make this a bit bigger for you guys. DW, what's that address? 0AA55H. Okay. I think these are just addresses you have to memorize. Okay, whoa. So that's make build directory, make, we're in our make file. Define that. Okay. Source directory, build directory. Okay. So apparently source apparently you could do something like like this. And set this to or this one would be SRC, this would be SRC, like this. And then this would be so that B slash main bin then we put our source directory into our main.asm. Apparently this goes there. Build directory. Okay. So then up here, here's where we create the floppy disk. So B slash flop image our build directory it's our binaries cp b slash main dot bin then truncate. Don't know what that means. Fort 49. I gotta do a recheck. Dash S 100. Okay. Okay. So here. Okay, put our build directory slash our flop dot image. Same thing up here. Our build directory slash flop dot image, and then apparently we just make it. Need to rename this to make file. Okay. Okay. Missing separator? What are they talking about? How did I not see the equal signs? 7 too. Let's see what's going on. I'm trying to see where I messed up here. So it's in directory 7. Oh. Oh. Oh, so this would be build. Oh my gosh, I'm slow. Build. Build. And this would be source. Source. Missing separator. Missing separator? What do you mean? Missing separator. Okay. Oh. Right here. Create a build directory. Create a build directory. Missing separator? What? Okay, wait. Build flop image. This, you think I want to see this, but I want to see the make file. How does it work when I do it? Oh my gosh. Okay. Okay, so now I think we can boot into this. So let's open VirtualBox. add a new one. Projects, OS. I know this is slow, guys, but Kimu just doesn't work. Is there a way to use Kimu command line? Or not Kimu, VirtualBox. What do you mean it's... Oh, it's an image file. Okay, wait, let me look this up. Let's exit out of this. Let's look up. For some reason, Kimu isn't working. Oh. There we go. Oh my gosh, in Face, just look it up. Okay, Kimu dash system dash I 306 FDA are I-386. Oh my gosh. Oh, here it is. Here it is. I'm so stupid. God, I hate PCOM. What is going on? Let's first get rid of this. This was our old project. Oh, that's not good. Okay, make cd source or build. Why isn't it showing GUI then? Jeez, I'm having so many problems with this. Okay. I don't know what any of that means. Real address equals segment times 16 plus offset. Okay, I want to print hello world. Move move the AX register, or 8 into the AX register. Move DS and AX. Move ES into AX. What does this do? He actually has. Can't write. Set up stack. Oh, we could set up we're setting up stack now? SS into AX. Zero X 7C 80. And we want to be running a syscall because memory access. Okay, so when we're writing to memory, we don't want to overwrite the memory in our operating system. It sounds like. So we need to call a stack so that we don't overwrite our um, all our stuff. So apparently we need to call the puts function. These instructions load a byte word double word from DSI into AEX. Then increment SI with the number of bytes loaded. Puts we push. Is that AL? SIAX. Up here we have to do dot start. We jump to main. Then down here we just loop LODSP. Load byte. Destination source. Okay. Or AL. And the character would be our... Okay, that makes sense. Jumps destination at 0 flag. JZ. JZ dot done. And then we gotta declare dot done. So a couple things we learned today. Jumping. So after we're done, we pop these off the stack. So pop AX, pop AL, or SI. So we put these variables in, so we're setting up a stack, essentially. You know, it puts those values at the top, and then when they're done with the values, they pop them off the stack. It's kind of like that. Do you call return? Shoot. Yeah, it's literally called the stack. Return. So I guess this is like the simplest version of the stack. Interrupt 10 in the video. See, this is cool. See, I learned so much today. You could use the pop command and push command to push it onto the stack and pop it off the stack. And then I learned a little bit about the memory addresses. I know these are functions. I didn't know that this memory address was the address that you put it in to load your operating system. So yeah, I learned a lot today. Equipment check. Okay, so the interrupt, we seem to interrupt that memory address, and I wasn't quite sure. So move to address. I think that was the address. And then we interrupt 0x030 or 10. And then we declare the message down here, apparently. So down beneath halt, message, eight, because I guess that's 1, 2, 3, 4, 5, 6, 7. Right now, it's not. And L0. Okay. 0, let's go back. Defined endl. Go up here. Define. Sorry, what does that say? Oh, endl 0x 0x0d 0x, I think it's 0a. Yeah. I don't know what any of these addresses mean. So move SI, so move the SI and, or move our message into SI. So what did he do? He did it on main? Underneath the halt function. He did move SI message. call puts. Oh my gosh. So technically we push. Oh no, see, that's cool. Okay, so we push our message into SI, and then we call puts, and then this takes the value in SI and pushes it to our stack, and then we wait for it to be over, and then we push it out and we pop it off the stack. Wait, that is so cool. Oh my gosh. That is actually so cool. Oh, right. Yeah, I was confused. We call puts. Then we just call puts. Yeah, I was wondering why, because this wouldn't be like this. It'd be like defined bytes, like that, and then apparently we jump to the loop. Okay. So this keeps looping. So with recursion. Wow. First, let's make it. Oh. Okay, wait. 31. Jeez. 31. I did forget a comma. What else? 39. What did I forget? CD out of this directory. A is not defined. Well, let's look at the GitHub and see where we messed up. So what does it say? 30, 29? Okay. I think this is only wrong because wait, 29. Oh, let's just neov vim into the source directory like that, and then we'll figure out wait, we still need the semicolon here. And then what are we missing? Let's go to 29 BH. lesson loop AX. So the AX register. That. Make it. Oh, it worked. CD build. Kimu. Let's exit real quick. Let's run this again. CDOS, CDR build directory. And now I don't know where it's at 100%. Here, let's look up why Kimu window isn't opening. Very much does. If you're running Arch from binary, make sure the local compilers. Desktop. Maybe it works now. Okay. Let's exit out of this window now. We run back. Shoot. Oh shoot. Oh shoot. Oh shoot. Oh, press Control Alt G. There we go. Boot failed, could not read from boot disk. Pretty weird. Let's just copy his code. See if his code works. rename or no, ASM, and then rename this to main. Then exit out. Make cd build, and then run it floppy disk. What did he do right that I did wrong? Oh my gosh. Oh my gosh. Okay, wait. Okay, wait. Now I gotta see. Okay. And then neovim. Okay, wait, let me see. This is why. I think. How did I forget push BX? How did I miss so many instructions? Move that into 0. Interrupt. Pop all these. Wonder if I have to do it in order. Okay, this should work. Bro. Sudo su neovim r.as, or actually let's remove the main file and remake it and paste everything in. And 0x7c00 bits 16, like that. Okay, now we can do it. Still? Booting failed? Puts push bx ax si jump main loop or ALAL JZZ dot done, move A, move BH, interrupt, jump to the loop, pop, return, move AX0. There it is. 0. I don't get it. Call puts and then halt. Bro. Am I missing something? Is this the right address? This is not the right address. How many mistakes did I make? Couldn't boot from disk? Why? You see, this one boots from disk. 510. See, this is why too. I keep making mistakes like this. This is probably the reason. Didn't even make it. Yes! Yes! Okay. Okay, that's good. Alright guys, I think that's it for today. We got hello world working. On that. Okay, I'm gonna go over everything I learned today. So that I don't forget. Not what I meant to do. Neovin. Okay. This means the address in memory that we store our operating system at. This is how many bits. I don't know what this means. This is the start of our program. We jump to our main function. I don't know anything about these registries. We create the stack right here. I think we move the stack into AX. And then we move our stack into the address that we put with the organization. We move our message into SI, and then we call puts. And puts pushes our message onto the stack. While loop is doing this too. And then if it's not that, then it jumps, or it runs done, and done or pops them all off the stack. So it's a simple little stack. And then down here, we define our message hello world, and then times, I don't know what this means, but and then I don't know what this means, but we can learn it. But anyways guys, that is it for today. I will see you guys tomorrow. Bye guys.